Hello everyone, good morning everyone, I'm Benson, and today I'm going to talk about the evaluation of marine pH sensor under controlled and nature condition for the Wendish and mid-ocean health express. And as we know, the ocean acidification has been a big issue in the whole world. And this figure is carbon dioxide and the pH mean chain. And however, this chain is just a estimated chain based on the carbon dioxide, but there are still another factor will affect this chain, like salinity and temperature. However, our ability to check on this chain is not good enough. Which I mean is we don't have a sensor which has not only has a high quality but also has low cost. So, what is this S price? Okay, this is SS price is a competition. Okay, it's not game, man. It's a competition like this, and it's worth $2 million for the scientists who can not only improve the performance and reduce the cost of the pH sensor. And this competition has 4 phases, and it is test the sensor in 3 different conditions: the laboratory trials, coastal trials, and open ocean trials. And in laboratory trials, they tested the sensor in stable regulated system. And the trees means it's a competition, it's a compound, which is widely used in the buffer solution, and it works to stable the pH. And in the coastal trials, it's test the sensor in the nature condition, and it might has possibility of biofouling, and this is biofouling. You can see on this picture. Some creatures on the sensor and affect the sensor. And in the first 4, the open ocean trials, the sensor will test in the range of depth in deep water. And how to grade? They grade in 5 aspects: accuracy, stability, repeatability, usability, and affordability. And affordability means how much do you need to buy this sensor. And also, this S price has 2 prices: the accuracy price and the affordability price. And of course, the accuracy price is more cares about the accuracy and the repeatability. And the affordability price more cares about the ease of use and the affordability. And before we upgrade these sensors, we need to know what is validation pH. Okay, we can see on this picture. This is a pH standard solution of pH 4, 7, and 10, and we have a sensor. And we put this sensor into the solution to calibrate the sensor. Means we record the pH of 4, 7, and 10, and then we will get the real pH value of 4, 7, and 10, and to put the sensor into our test tank, and we will get the real condition of the test tank. And another way to validation the pH is the spectral photometer, and it will have a high accuracy. And after we know the validation pH, we need to know what will cause the uncertainty, and we estimate the uncertainty of 0.011 as a standard deviation for us to create the sensor. And let's talk about the phases of competition. And the first one is registration, so it's not important, so let's just skip over it. And the first 2 is laboratory trials. It's test sensor, everything was allowed to submit 3 sensors, and the test sensor in the buffer of salinity certified, and 2 different pH level. And they are allowed to calibrate the sensor after this test and choose one for the following test. And after the first 2 ways, we are a little jigsaw again. And look on this figure. The x-axis is tins. Y-axis is the residuals of pH sensor and of the sensor pH and the validation pH. And the dashed line, the dot line, are the minimum standards which was mentioned before. And the gray area is the validation uncertainty of the validation pH. And the color and the shape means different thing and the different sensor. And we can see on this picture, this figure, there are 9 of these things will get points in the accuracy price, and 2 of them will get points in the affordability price. And in first 2B, the test sensor in a is a long-term test. The test sensor in a big tank like this, and the tank condition will gradually increase the pH and the salinity. And the real tank condition will monitor with acidity and the pH sensor. And after the first 2B, we will see on these 2 big figures. The x-axis is sensors, and on the left figures, the y-axis is the residuals of the measurement, this gray dot, and the white dot is the standard deviation, so we can know the repeatability of the sensor. And the figure on the right, we can see the y-axis is the pH interdecile range, and interdecile range means the distance between the temp and the 9% of this measurement data, and the smaller the distance is, the stable the most stable the sensor is. So we can see over half of this thing has a good performance in these 2 tests. And in the first 3, the coastal tribes, it's test beds in the Seto area, and they pump seawater from the area bay, and they monitor the tank's condition as first to be. And after this test, we can see the x-axis and y-axis are the same as the first to be, and we can see although there are 5 things still have a good stability, but we can obviously see that all the things performance of the sensor has been affected by the nature condition. And in the first 4, the open motion trial, every sensor will fix on the hydrocast. Hydrocast is like this, and it tests the sensor from the range of 250 meters to 3,000 meters, and it collects 15 depths of the seawater. And after the first 4 tests, you can see this figure. The x-axis is the sensors, y-axis is the residuals between the pH, sensor pH and the validation pH. And we can see that the color bar means the depth. And we can see on this figure, almost all sensors performance, the accuracy of all the sensors will decrease. Accuracy will decrease with the increasing of the pressure. So after the test, we know how sensor accuracy, stability, and repeatability can be evaluated in this test, and it also shows the ability to collect the high quality pH measurements in a range of the conditions. And this express is not only a competition, it's also encouragement for all the scientists to improve the technique of the pH sensor making. And this is my conclusion. In the test before, we know the best sensor of this computer still has an accuracy of 0.02, which is not really good, but it's actually not too bad in deep water. And in this competition, we hope a cheap and high quality sensors will come out soon through this competition. And through this competition, we can get a sensor that have a cheap and high quality that can widely used in every world around the world. Like some countries didn't have a rich laboratory that can buy very expensive sensor. So this is that I didn't mention in the in the front slide that this express can let us detect the pH changing in the whole world. Yes. And that is thank you.
All right.